Okay, another video on half-life. So half-life is given the symbol T with a subscript to half, so a small half there next to the T. So that represents 1 half-life, 2 half-lives, 3 half-lives, 4, 5, and a general formula for any number of half-lives, n half-lives. So what we know is after 1 half-life, there's half of the amount of undecayed radioactive material still left. So if there were 100% radioactive material at the start, after 1 half-life, whatever that is for that element, only half of that radioactive material remains. After 2 half-lives, half of the original half is left. After 3 half-lives, which is another half-life on from that, it's half of the previous amount. So it's half, a half, a half. 4 half-lives, a half by a half by a half by a half, 5 half-lives, and so on. That gives us a general formula then for the number of half-lives and the amount that's still undecayed. So after 1 half-life, the amount that's undecayed is 1 over 2 to the power of 1. After 2 half-lives, the amount undecayed, so the amount that's still radioactive in the sample, is 1 over 2 to the 2. 3 half-lives, 1 over 2 to the 3. 4 half-lives, 1 over 2 to the 4, so on and so forth. So for any number of half-lives, the amount that is undecayed still in the sample is given by 1 over 2 to the power of n, where n is the number of half-lives. And that's very useful, and we'll see that we'll use it to correct the homework in a moment. The other thing that you need to remember is if half of it here is decayed, that means there must be half undecayed. If a quarter is decayed after the second half-life, 3/4 is undecayed. If an eighth is undecayed after the third half-life, then that means 7/8 has decayed, and so on and so forth. So it's just 1 minus the amount that is undecayed to calculate the amount It's 1 minus the amount undecayed to calculate the amount that has decayed. So if we think of something like polonium again, and polonium decaying to something like lead, Pb, there's the radioactive nucleus, there's the stable nucleus. After 1 half-life, there'll be a half of the polonium that was originally in the sample present. Half of that will be converted to lead. After the second half-life, there'll only be 1/4 of the original amount of polonium present in the sample, and the remainder will be in the form of lead, so 3/4. After 3 half-lives, there's 1/8 of the original amount of polonium, the original radioactive substance in the sample, so that means the remainder, which is 7/8, was converted to lead, and so on and so forth. So after n half-lives, there's that much of the radioactive sample left, and there's that much decayed. Okay, let's go to the questions. I'm going to start with questions 3, 4, and 5. So the half-life of a certain radioactive isotope is 3 years. What fraction remains undecayed? So in other words, how much radioactive substance do we still have after 3, 6, and 9 years? So 1 half-life is 3 years. That means there's half of it left undecayed. That's the answer for the first part. 6 years is 2 3s, so 2 3 years, so 2 half-lives. So there's half of the half remaining, so that's 1/4 undecayed. And then 9 years is 3 half-lives, 3 3s. So that means we have half of a half of a half, so 1/8 of the radioactive substance is remaining at that point. Question 4. The half-life of a radioactive isotope is 10 years. What fraction remains undecayed after 40 years? So if 10 years is the half-life, 40 years is 4 half-lives. So that's 1 over 2 to the power of 4. So 1 half-life is 10 years, 40 years is 4 half-lives. And we know that after 1 half-life, there's a half of the radioactive substance left. After 4 half-lives, it's a half of a half of a half of a half, 4 halves basically. So it's 1/16 of the radioactive substance left. The second part of the question is how much of it has actually decayed. So if there's 1/16 of the radioactive particles left, that means 15 over 16 has decayed at that stage. Final question. Half-life is 20 minutes. How many half-lives in 5 hours? So in an hour, there are 3 20 minutes, so 3 half-lives. 5 hours then would have 5 times that amount, so there'd be 15 half-lives. You'll see that in a moment. What fraction remains undecayed after 9 hours? So how many half-lives? It's 9 half-lives. So the fraction undecayed is 1 over 2 to the power of 9. The fraction decayed in 40 minutes. Now we know 40 minutes is 2 half-lives. It's 2 20 minutes. So that means it's a quarter of it is undecayed, and we're asked how much has decayed, so it's 3/4. And that's the general formula for half-life. So let's have a look at it. Half-life is 20 minutes. We know that 3 half-lives is an hour, but we're looking for 15 half-lives, which is 5 hours, and the answer for part 1 is 15 half-lives. The second part, what fraction remains undecayed after 3 hours? So we know that 3 hours is 9 20 minutes, so 9 half-lives. That means if we use 9 there as the power, it's 1 over 2 to the 9 is left undecayed, which is 1 over 512. So that amount of the original substance remains undecayed or still radioactive. Then, how much is left decayed after 40 minutes? 40 minutes are 2 20s, so 2 half-lives. A quarter is left undecayed, so 3/4 has been decayed. And then finally, n half-lives, there's 1 over 2 to the n left undecayed. Send me a message, lads, if you run into any problems with those or have any questions.